Hi folks, this time we are going to talk about the combined gas law. Now, these are discoveries made by a variety of scientists over many years, and they're talking about the behavior of gases when there are changes in temperature, pressure, and volume. Now, this is the combined gas law in an equation form. It expresses pressure, volume, and temperature. And in this video, we are not going to go into the mathematics of this law. We're just going to describe what happens to each one of these variables when you change the other. Now, typically, that combined gas law is divided up into three laws: Boyles Law, Charles' Law, and Gay-Lussac's law. So we're going to talk about each one of these in turn. So first off, Boyles' Law. Boyles' Law refers to a situation where pressure and volume change if temperature is kept constant. So I like to refer to it or think about it as the piston law. Now, in Boyles' Law, here's how this works. If you have something like a cylinder in an internal combustion engine and it is compressed, the gases are compressed. If the pressure goes up, volume goes down. If the volume goes up, the pressure goes down, under the assumption that essentially the external temperature during this process has not changed dramatically. That's an example of Boyles' Law. And there are lots of examples. Here's another one. Breathing. When you breathe in, the diaphragm, and you can try this by holding your diaphragm. When you breathe in, your diaphragm contracts and the volume of air actually in your lungs gets bigger. And this lowers the pressure. Well, as you know, gases go from low pressure to areas of high pressure, and the gases go that direction. When you breathe out, the diaphragm relaxes and the volume here decreases, which increases the pressure here. And again, gases move from areas of high pressure to low pressure, and the gases move in that direction. This is, again, Boyles' Law in action. Change in volume, change in pressure. High altitude balloons that are used for all sorts of things, from scientific research to weather and a whole bunch of other things. Typically, when they're launched on the ground, they're kind of big sacks with a lot of extra room in them, because on the Earth, close to the surface of the Earth, the atmospheric pressure is relatively high. So the volume of the balloon, the actual gas volume in here, is relatively low. As they rise high up into the atmospheric pressure is very, very low. So the volume of the balloon itself actually expands and gets much larger. Again, another example of Boyles' Law. This is kind of a fun one. People who work with these little submersible subs that go much deeper than a diver could dive by themselves in an open water dive. Some of these little subs can go a mile deep or many, many miles deep. Often will hang on the outside of their submarine. They will hang bags full of styrofoam cups, and then they decorate the styrofoam cups and they look at them before and after the dive. Well, a styrofoam cup is about 90% air. If you take a styrofoam cup a mile down, what happens is, because of Boyles' Law, the volume greatly decreases because of the pressure at those tremendous depths. And you get some weird and wacky changes in the cup that occurs because of this massive change in pressure. And of course, this is why you need the submarine and can't go down just with your little body and do that. Many of us have flown in commercial airliners and have experienced the popping ear phenomenon. At ground level, the pressure in your head matches with the pressure outside, and so it has a relatively small volume. You go up to high altitude, and in the airplane, the atmospheric pressure is going to be lower. So the volume of gas is going to increase, and you're going to have to swallow a lot to equalize that air pressure inside and outside your ears. Another thing that can be observed at those high altitudes is maybe, not maybe, but foods are typically packaged on the earth, not in airplanes. And there's a little bit of air in your chip bag, but if you take it up to high altitudes, those chips just swell, and food products are going to swell at those low altitudes because it's going to be a low pressure and you're going to experience high volume. Here is a cool collection of pictures that I found of a empty water bottle at a relatively high altitude in the atmosphere, and it has a large volume, and as this person went lower and lower, the volume of gases got smaller and smaller as they got lower in the mountains. Pretty cool stuff. One of the fun things about Boyles Law is joint pain. I guess that sounds terrible, didn't it? That joint pain can be fun, but it explains it, and I love it when science explains things that we experience. A lot of people with arthritis or who have had an old injury or people who suffer from migraines will tell you they can tell when it's going to rain or when the weather is changing. Well, a lot of time that means a low pressure center is coming in. Low pressure centers mean that the gases that are trapped in these old injuries, gases that are trapped inside of your body, are going to expand. There's always a change of gases between the inside and the outside of your body, but those exchanges will not happen fast enough for your body to equalize those pressures quickly enough to avoid this pain. So what happens is this: if you've got some trapped gases and a low pressure center arrives, what happens is the low is going to make the volume of the gases inside your joints expand because of Boyles Law. When these gases expand, they are going to push on the nerve endings and the tissues around them, and this is going to cause pain. So your great Aunt Frida, when she tells you her knee hurts and can tell you it's going to rain, she's not funning with you. That is a real scientific fact, and it has to do with gas laws. This is another one, a little weird, but if you've ever traveled to the mountains, you may have experienced this. People have a tendency to be a little bit more flatulent at high altitudes when they travel from low to high altitudes. Inside of us, we have a lot of internal gases, belly and bowel gases. And when you go from low altitudes to high altitudes, and there is a low pressure outside, these gas bubbles inside of us get bigger and they have to come out. Well, if they're low inside of our bodies, in our bowels, they're going to come out typically in the form of flatulence, and it is not your imagination that people toot more at high altitudes or when they get up in airplanes. It is gas laws in action. All right, let's talk about Charles' Law. Now, Charles' Law is another example of this combined gas law, but this one involves changing temperatures and volumes. I like to call this the hot air balloon law. It's because a hot air balloon, the volume goes up when the temperature goes up, and the inverse would also occur. As temperature goes down, volume would also go down if pressure is constant. So this is a situation where pressure falls out of the equation, and we're just talking about changes of volume and temperature. Another example of Charles' Law is buying balloons, and you may have experienced this. If you buy balloons in a store, and let's say the temperature in the store is about 70 degrees Fahrenheit, you take them outside or into a hot car on a very hot day, the balloons will expand, and that expansion is due to that temperature going up, volume going up. And I've had many students tell me that they've done this, put their balloons in a hot car, and the balloons actually explode. Well, that's a gas law. If you take them outside on a cold, cold day, they will shrivel up and they're going to get to be sad little balloons because when temperature goes down, volume goes down. But you take the balloons back into a nice warm house, they expand and they're pretty again, and you can give them to your sweetie. Ping pong balls have a tendency to get dented. It happens. How do you undent a ping pong ball? Well, you can put them in boiling water or hot water, because when the temperature goes up, the gas inside the ping pong balls is going to expand, and Charles' Law to the rescue, it's going to undent your ping pong balls. When you bake, gases are released, usually carbon dioxide, a little bit of water vapor also is released, and those gases that are released in the baking and cooking process are going to, because of the high temperatures in your baking oven, like 350 degrees Fahrenheit, are going to get to be big amounts of gas. The volume's going to increase. That is going to make these lovely big holes inside of your bread, your cookies, whatever, and that high temperature is going to create those high volume. Then those holes are preserved by the baking of the goods around them, and it makes things nice and light and fluffy. Another example of Charles' Law is burping. Hate to even to talk about this, but yep, this is the way this works. You have a warm tummy. You drink a cold soda. Soda pop contains a lot of carbon dioxide. You put cold soda in your warm tummy. The gas bubbles expand. The gas, as the volume goes up, it has got to go somewhere. Yeah, out it comes as a burp. Last of the three is Gay-Lussac. Gay-Lussac, what happens if volume is constant? Well, this is the exploding can law. So if we keep volume constant, as temperature goes up, pressure is going to go up. Please don't do this at home, but if you ever throw an aerosol can into a fire, it's going to explode because the pressure is going to increase to the point it will destroy the integrity of that can. This happened to my son when he was small and visiting his grandparents in Arizona. They put a case of pop in the trunk, driving across the hot Arizona countryside, and they're in a nice air-conditioned cab of the car, but out here it's 110 degrees Fahrenheit, and they're driving down the road, and all of a sudden they hear bang, bang, and they're going, what the heck's going on? Well, the cans in the back of the car had gotten so hot that they were rupturing. They opened the trunk of the car, and they had pop everywhere. It was a mess. I'm glad it was not my mess. And here's another one that is a common story that is weird. And when I first heard it, I thought, this is an urban legend. This doesn't really happen. But these biscuits in a can, well, the volume is trapped because it's inside of a can. But I've heard stories about people driving down the road and all of a sudden their biscuits explode when they're coming home from the grocery store. Well, it happened to me. I was coming home from the grocery store and I had my groceries in the back seat of the car, and all of a sudden I heard pop. And I'm going, what the heck was that? And I was taking my groceries out, and this is not my picture. I found this picture online, but yeah, my biscuit can had exploded, and it's just because the volume is constant, but as the temperature in my hot car, it was a summer day, went up, the pressure got big enough that the biscuits kind of exploded all over the place, and yeah, I had to make biscuits right now. So that's the ideas behind all of these gas laws. We're going to come back next time, and we're going to do some math with these. So we'll see you soon. Bye-bye.